PM Research Lathe Kit, Day 1. There's an awful lot of pieces here. As a matter of fact, there's 133 parts that need to be fabricated, and the blueprints are relatively clear. The one thing that's not on these prints, and I was quite surprised to see that, is the item number. It tells you what the item numbers are here on the print and how many of each to make, what material it's made out of, or whether it's supplied as a casting. But when you get to the drawings, there's no item number on any of the parts, which I think is unfortunate. So the first thing you're going to have to do is tag them up. Find the part, put the number on the drawing so you know what to make it from. There's a million different places that we could start on this model, but I think I'm going to start with something just to have a little bit of fun, and I'm going to make this little tool post assembly today. It is going to be extremely small. Well, since this lathe is so big, right? This has approximately a 3/4 of an inch swing, 19 millimeter swing. And if I am correct, then that would mean the faceplate is 1.5 inches in diameter. 1 3/8 in diameter, so it's actually under 19 millimeters. And that is to the ways, that's not to the cross slide or the carriage. These are the parts I'm going to be focused on today. Tool post, the base, the wedge, and the washer. Make a nice little assembly. You're going to see a lot of the techniques that I will use on this are very similar to, if not identical to, the techniques I demonstrated on the steam engine. So that means we're going to leave this connected to the bar, to the raw material, so you have a place to hold it for the slotting. This is going to be very delicate. You could squeeze it end to end, of course, to do that slot, but I think it's just going to be easier to leave it on the raw material that it's connected to initially. This is done out of a washer. So you just take a little washer and you just section a piece off, which is pretty clever. And then make sure the radius in your tool post washer fits the outside radius of the wedge. You want a nice little rocking action when it goes in there. That's it. Let's take a closer look at the assembly print. And this is actually just an exploded view. They do not provide assembly sequence on this. There are some notes, assembly notes, tell you what looks what gets pressed into what's a slip fit. And there's the infamous 4-jaw chuck. I'm looking forward to making that thing. That's so tiny. That's about actual size. That's how big it's going to be. Little thing. 25.4 millimeters across. Anybody's curious where this came from? Right there, PM Research. Got quite a variety of stuff. Check them out. All right, let's get over to the lathe, put some material in there, make some parts. First couple operations here are very straightforward. We're going to do the two diameters that are called out on the print, a 125 and a 154. Straightforward turning. Let's do it. You have a couple of options for the 15-degree lead. You can do it with a form tool, or you can set your compound to 15 and cut it. If it's more convenient, use a boring bar and run the machine in reverse. I'm going to use a form tool. The only danger of a form tool is there's more surface contact and you risk the small diameter climbing up and over the tool. Slotting operation will be done in a square collet block in the mill. Pick it up like you would pick up any other part. Find the center of it, find the end, and we'll dial in accordingly. I'll show you the numbers that I'm going to use. I'm going to drill a series of 5 holes in this small part, and then I'm going to pick away at it with a 1/16 4-flute end mill. You can expect some flex to this part, so if you can support it, do. You don't have to, but not a bad recommendation. Spot face features are very small, so is the drill that's about to come. 0.55 in diameter, and we're going through with it. Make sure the drill is nice and sharp. Watch for the flex of the part. I expect the part to bend down just a little bit because that's only 1/8 of an inch right here. If you want to, put a piece of wood under it and just drill straight through into the wood, or a piece of aluminum would work as well. Just don't mess up your parallel. When you put the hole through this part, it is going to reduce the cross-section of the material. So by working from the outside in, you'll always have a full cross-section of your part right until the very last hole. If you were to drill this hole first, you would reduce that cross-section. Subsequently, as you pulled out with the drill to do these other holes, the flex or movement potential would be far greater. Let's put an end mill in there and do the exact same thing, but smaller steps. This is a 1/16 4-flute carbide end mill. I'm going to start on the outside hole and walk my way in. When I'm done, I will sweep the entire slot 1/1000, maybe 1.5 off center each way, just to get a nice cosmetic wall. Be real gentle with this approach. As you peck away with a cutter like this, it is going to want to walk to the spinning side. It's going to want to walk to this side towards the operator, just because it's spinning clockwise. So peck through it nice and easy, take small bites, and you should end up with a nice clean wall. All the drilling for the next operation is going to be done with my micro chuck adapter. If you haven't watched the video on how this is done, this is a standard Jacobs chuck, 3/8 capacity. This is a piece of 1/2-inch drill rod that's been turned down to 3/8 and reamed. Another cross hole, and then my micro chuck on the end simply floats in and out. I will push this in by hand. I will not use the crank. I will get the tailstock close to start the operation, and all the drilling, all the center drilling you're going to see is going to be by finger pressure, just like that. Gives you a great feel. If you don't have one, make one. Setup works very well when there's resistance on the drill, but be careful if you're breaking through to a slot or a cross hole. It will have a tendency to take off on you, so anticipate that. Spring-loaded narrow tap guide. If you have one of these, make sure you put a light spring in it for the smaller taps and softer materials. You don't want to drive an 080 tap in with the same pressure you're going to use for a half 13 in stainless. Not going to end well, guys. Make sure you know how much stroke you got on it. Preload it. Take your time. Boy, I would normally be coming over the top with my hand, but I think you guys have seen enough pictures of the back of my hand for a while, huh? These little wheels work really well. You can actually feel the text flapping, the tap flexing as you drive it in. Treat it like anything else. Back it off and clean it. There we go. Beauty. This is not the kind of operation you want to do with a T-handle. It's just not suggested. Make sure you use one of these tap guides, or even a broken end mill or broken tap that has a small countersink in it. Use that as a guide. Clear the smudge off of it before we get it out. As you're backing it out, listen for it to click, or wait for it to click. You'll feel it. There it is. Okay. I might be wrong, but I think that pushed back in the chuck. I don't even know my own strength. There we go. Okay, clean it up, deburr it accordingly. Let's part it off the length. This part will be done. Try not to overpower the part with a huge parting tool. Small part, small tool. Part is 500 long, 12.7 millimeters. So I'm gonna, don't have the razor blade right with me, so I'm just gonna use my little scale here. Part it off longer than I need to. I'm gonna flip it around and face it. Don't be fooled, just because it's small doesn't mean it can't get hot. Watch your fingers. Well, watch your fingers anyway. You might want to just put a cup or a rag or something under the part and not get your fingers that close to anything that's spinning. Especially if it has a slot in it, it's like a blender, so be careful. I am using a different camera setup for this, so if you like what you see, if it's working for you, leave me a comment. Final product is 12.7 millimeters long. It's about 3 millimeters in diameter. For all of my Imperial friends, 1/2 inch long, 125 diameter, 154 head. It's a 1/32 shoulder on that, so it's about 0.85 millimeters thick on the end. 080 screw, that's 060 diameter. That is an 060 diameter screw, 1/16 of an inch, 1.5 millimeters also. And I think just by the size of my fingerprint, you can tell how small this thing really is. Got to start somewhere. Start with the small stuff to give you confidence, because it can only get bigger from here. I promised I would show the numbers that I just used on the print. 5/16 on the print. That's the overall length of the slot. And that is the overall length. That is not center to center. That's the overall. So make sure that you subtract or add the radius of the cutter accordingly, like I did here. First hole was at 126, 1/8, 3/16, quarter, 5/16, and 3/8. Easy. It ain't pretty, but it worked. The tool post base is going to start from 5/16 diameter cold roll, and I am going to do this backwards. So it's going to start from a round piece, just like it's shown, but I'm going to be able to drill and counterbore from one side, so it's going to be hanging out of the machine this way. I'll take it over to the mill. I will mill the face off, or actually just make contact with it. Do it in a spin indexer so I can rotate and get the 185 width. And I will step the end mill up and over and do the back side and bring it back to the lathe and part it off. This is going to be a whole lot smaller than it looks when it's done, and I would like it to be done when it comes out of the machine. Let's do it. Okay, whenever you counterbore a piece after you've completed the through bore, double check the through bore to make sure you didn't close it up from the pressure of the cut. This was minimal, but the potential still exists. Let's take it over to the mill, put the flats on, put the inner flats on, bring it back and part it off. Okay, we're going to take a small dust cut, a witness pass across the front of this. Then we have everything we need. We don't need an edge finder or anything else. This is a spin indexer. I'm going to do all the cuts by rotating the part and not anything else. I could do it side to side, but stepping in like you'll see is probably the better choice. First thing I'm going to do is just bump this face with this cutter to establish a 0. Let's do it. The goal here is to end up with 1/32 shoulders on either side of this part. So by doing what I just did, let me get the cutter back into frame here. I know that the inside of the cutter is now true to the face of the part. So if I zero my digital or my dial, when I move in the diameter of the cutter, I know that from that point on, any shift that I make will give me the edge that I'm looking for. To clearly illustrate that, I know this is a 248 cutter. I'm going to pull the part towards me, 248. I'm going to zero the digital at this point. Now if I want to put an undercut on here that leaves me with an 031 shoulder, an 031 shift, and when I plunge this cutter down into this part, the edge that it leaves right there is going to be 031 thick. Let's do it and test that theory. Pull back on this just a hair. All right, here we go. I'm going to do the outside first though. Outside first, the 185 across the flats. With the outer flats established, I can move the cutter on the y-axis however thick I want my little T-nut edge to be right there. And that is 32 thousandths. Shift it in, check it out. Excuse me, it is 62 thousandths, not 32, 62. That is almost undetectable even on the camera. Sorry about that, guys. We got a close-up look on the bench here in a second. We got a dimensional check for final cut. Here we go. And you can see how the process works. Once you know the diameter of the cutter, it's easy to shift in the body diameter and then just a little bit more to give you whatever shoulder you're looking for, pretty much with no headache whatsoever. Going to deburr this part, put it back in the lathe, and part it off to the final length of 1/8 of an inch. Finished length of the part is 1/8 of an inch. This is my famous razor blade parting tool trick. Dragging the front of the part with the razor blade. No obstructions, no hang-ups. When it starts to click, I know the parting tool is right there. There you go. Until the click goes away. Zero out your digital, your indicator, whatever. Want to move it in 126, gives me something to clean up on emery if I have to. This will be an interrupted cut. Get ready to catch it with something. see that. That is a very small piece. And we'll clean off any uglies left over by the corner round on the parting tool. Obviously there's a break edge on it, but that'll come right off. And that wraps up that part. Let's get a closer look on the bench. And there is the results of today's effort. Just for fun, let's put that on the post. Just for fun. Done correctly, the post should be subsurface to the bottom. Nice symmetrical flat. It should spin freely, which it does. So now we got to make the concave swivel washer and a tool bit. Let's keep going. The next piece I'm going to make will be this tool post wedge, and they tell you to make it out of a 1/4-inch washer. But the edges of a 1/4-inch washer are not all nice and crisp and sharp like that. So I've got a piece of 3/4 stainless laying around, and I'm going to show you a way to do this from a piece of 3/4 diameter stainless. And it shouldn't be all that hard. If all goes well, it shouldn't be that hard. All right, this is the setup. Nothing fancy here, guys. We are back in the lathe for this part. I'm going to face this off, and I'm going to part it part of the way through until I can work that back to the 1/16 of an inch that I desire. Thickness. I'm not going to part it completely off. It's not going to happen until it gets to the mill. Let's do it. All right, easy to start this one. Face it off, put an undercut in it, we're going to the mill. All right, now I think you can see why they say it's easier to do this out of a washer. But I'm just not content with a washer. So part this part of the way through. Get it down to the 63, 64, whatever you're looking for. I want to see 63, so I'm going back in there. That's all you need to do to start right there. Okay, let's go to the mill, make it look like a wedge. Anytime you go from a lathe to a mill with a round piece, you know you start off with an indication of the part. There you go. We are just going to take a little piece of this and we're going to bite it off and we're going to make a part that looks exactly like that. I can't give you the numbers on it because depending on what size cutter you use, your numbers will change. But I'm going to put a slot in it on either side of center, and then I'm going to walk back and forth until the wedge just starts to fall off, and I know that I only have one really nasty edge to deburr. That'll be a really surefire way to make this wedge. Let's put this camera on a tripod. What a beautiful picture that is. Put the camera on a tripod and we'll make it happen. Note to self, guys, if you're going to grab a piece of scrap metal, if you're going to grab a piece of scrap metal to do this, don't grab a piece of 304L stainless. This stuff is just nasty. 17.4 would have been a better choice, but 303 would be even better. All right, let's make a wedge. Okay, up until this point, this is a fantastic way to do this if you're using a 1/8 cutter, which I'm not. Put this one on the calendar. Thank God this happened on the 12th of January. Get it out of the way. I added a 1/16 of an inch to my radius offset instead of an 1/8. Boo-hoo. That's going to have to move this part around the back and do that again. Not a problem. But there you go. It happens. And it just did. Okay, anybody that's paying attention knows that the camera angle changed and we have an unfinished feature on the back side. Well, that's because my calculator gave me the wrong number. I think the batteries must be dead or it's a defective calculator. I don't know. So we're going to try again on the back side here. Actually, I'm going to fess up and say I calculated all my offsets for a 1/8 cutter when it's actually a 1/8 radius 250 cutter. So put that on your calendar. I'm glad I got that out of the way. I'm safe for the rest of the year now. Let's try again. All right, now you can see the wedge starting to form right here. That is the part that I'm looking for, the remnant that's going to fall off. But let's see if I'm right about this speculation here. Since it's attached towards the center, I can expect this to end up as a really sharp razored wedge looking burr right there. I do not expect this to fall off clean. If it does, I'll be shocked. If you do want it to fall off clean, make the undercut that you put in here, this where I drove the parting tool in, make that just beyond the thickness of the part that you want to have fall off. That way this little diving board that I'm forming here will have the most support possible. As expected. There you go. There's the wedge we're looking for. Pretty good picture of it too. Clean it up without hurting your ears. That is one of those one-way pieces, I call that. You're not going to put that back in there for any extra work. Let's pop that out, clean that thing off, and deburr it and add it to the assembly. That was fun. When you're done with your tool post wedge, it should look like this. The very next piece in line will be the cup that it sits in that gives you the height adjustment in the tool post. And how small is that? That's how small it is. That is tiny. I'm looking forward to seeing this thing go together. You can't do it from the washer like they suggest, but I wanted nice square edges on mine, so I did mine the way I did it. 304 stainless. Another piece done. Let's move on to the cup. Last piece in the setup right here is the tool post washer. The only thing difficult or even challenging about this is this radius right here, and you could probably put an angle in here if you had to, so long as this wedge sits in there nicely and articulates back and forth on the edges, not on the center. On the center it's going to be a little bit less stable. 5/16 cold roll, 1/8 inch through. See if we can grind up a tool real quick and do something about that radius, get this done. We're going to use the remainder of the material from the T-nut. Flatten off the face, continue with the 1/8 inch hole, and put a dish in the front with the form tool. Form tools with a radius form tools are not that hard to do. The hardest part about a radius form tool is getting it on center, vertically and axially. See if we can get lucky here. I do have a radius gauge, and this is a form tool I've had for quite a while. I'm just going to try to line up the peak of this radius, the face of this jaws. Doesn't give a specific depth, but it does show an edge around the radius, so let's not go too deep with this. Well, I hope the camera got that. That is really superficial. Radius gauge itself should sit right in there. And that is really hard to tell exactly where that's registering. I'm going to block you out here for a second, forgive me. Like it. Do yourself a favor and keep your lathe clean while you're doing this. You drop one of these, you'll never find it. Little dish in the face, 1/8 inch through. Break edge on both sides. I'm going to run it on some emery. Let's put this thing together. Anybody that may be curious as to whether or not that's an actual real tool bit in there, it is. What I did, I took a section of a parting tool and I cut it off with a Dremel. So the T profile that you see is actually the profile of the parting tool, but now it's laying down. And yes, that is a high-speed steel tool bit in there. That is about 040 by 060 with a little bit of nose on the front. So I'm going to bet that that will cut when the time comes. Everything is made out of steel with the exception of the wedge. The wedge is 304 stainless. And I guess that's about as real as it gets. Appreciate you watching. I hope you enjoyed that. There's more to come. Take care. Joel Pye, Advanced Innovations in Austin, Texas. I'm out.